let's see example 2. You have y equal to inverse secant x to the power of 4. So we can see that this is a composite function, so we need to apply the chain rule here. So differentiate outside first. Inverse secant. Inverse secant ayam is 1 over modulus ayam square root of ayam squared minus 1. Okay, so let's rearrange everything here. And then further differentiate ayam. This is just 4x cubed. So now let us open up modulus of x to the power of 4. So let's see here, we already know that if it is odd function, modulus x is equal to x if x is positive. This is equal to negative x if x is negative. However, if your modulus is even, modulus x squared, this is equal to x squared if x squared is positive. And this is equal to minus x, everything squared, if x squared is negative. So you can see here, if you solve this, this is also a positive function, x squared. Okay, so we can conclude that if we have a power even, modulus of even power x to the power of 4, this is just equal to x power of 4. We can just drop the modulus. So let's do that. This is just x to the power of 4. And then your numerator here is a common term. You can cancel out. So you are left with 4 over x. So x to the power of 8 minus 1. That is your final answer. Now, let us see the final question here. This is y equal to 4x to the power of ln 2 and multiply with inverse tangent x. Everything is to the power of 3. So you can see that the first term here, this is just a power rule because x to the power of constant. And this one, we need to solve by chain rule. Why? Because this is ayam to the power of 3. And you can see that these two functions are multiplied to each other. So of course, you need to use product rule here. So let's do this. 4 is a constant, put it outside, and then put a big bracket here. And then let's solve this by using product rule. So keep the first one, differentiate the second term. So this is ayam to the power of 3. So bring down the power reduced by 1. 3 ayam to the power of 2, further differentiate ayam. This is just 1 over 1 plus x squared. Plus, keep the second term, inverse tangent, cubic, and then differentiate the first term. So this is just a power rule, so bring down the power reduced by 1. So ln 2, x to the power of ln 2 minus 1. So now let's simplify our answer here. So this is just 3. And this term here, x to the power of ln 2, and we have inverse tangent squared over your denominator, 1 plus x squared, plus, and then let's rearrange, put this term here, multiply by ln 2, multiply by this function here over x. So you can see here that you have a common term. This is the same term, so you can bring it out, factorize it. And for this function here, inverse tangent x, you have common term, but this is power of 2, this is power of 3, so let's take out the lowest one. So take out inverse tangent to the power of 2. So you're left with 3 over 1 plus x squared, plus, and here you're left with ln 2, one of this factor here, inverse tangent x over x. So now let's further simplify this. Let's equate the denominator. So this should be multiplied by x, and this one we should multiply by 1 plus x squared. Okay, so we'll get this function here. So finally, you can see that you have x here. You can just bring it out. So if this is over x, and then the power will change to x to the power of ln 2 minus 1. Therefore, this is your final answer. So that's the end of this chapter. Assalamu alaikum warahmatullahi wabarakatuh.